This is an AIPMT question in thermal properties of solids. The problem is like this. Steam of 100 degrees centigrade. So, though it is something like steam, I would like to specially mention something like some steam, not unlimited steam. Some steam is actually passed into 20 grams of water at 10. Water requires a temperature 80. Mass of the water present. When he says mass of the water present, again, he need to ask specifically like total mass of the water present. Assuming specific heat of water is 1 calorie per gram per Kelvin and latent heat is steam is 540 calorie per gram. Well, let's understand few things here. First of all, that steam is the hot body here that releases heat. Water is the cold body that absorbs heat. According to principle of calorimetry, when there is no loss or gain of the heat from the surroundings, heat lost by hot body equal to heat gained by cold body. That is principle of calorimetry. So, steam loses heat. Steam is at 100 degrees centigrade, but at 100 degrees centigrade, before the steam loses heat, first of all, it has to convert into water. This conversion happens at a constant temperature, that's at 100 degrees centigrade. So during this process of converting itself from steam to water, it releases some heat. How much is that? Based on the definition of the latent heat, ml. Now it is converted into water at 100 degrees centigrade. But he said when water requires 80 degrees centigrade, the common water requires 80 degrees centigrade. Therefore, for the equilibrium to obtain, this steam converted water falls itself from 100 degrees centigrade to 80 degrees centigrade, and for during that also it will release heat. The formula for that is based on the definition of specific heat, ms delta T, where m is the mass of the steam, this m is the mass of the water that is converted because of the steam. So heat lost by the steam is ml, mass of the steam into latent heat of the steam. Now it is not in the steam format, it is in a water format. Still the mass remains same, mass of steam converted water. I am writing like SW, specific heat of water because it is water, and delta T is heat gained by the water. This is the heat given, water given, right? So mass of the water given into specific heat of the water into delta T of the water. This water is at 10, it has to get 80, so it has to rise its temperature from 10 to 80, right? So mass of the steam is not known for me. Latent heat of the steam is 540. This is the same mass of the steam which is converted into water. Specific heat of the water is 1 calorie per gram per Kelvin. This steam converted water is at 100, but to get equilibrium it has to fall to 80 because given temperature of the water is 80. Equal to mass of the water given is 20. Specific heat of water is 20, whose temperature is raised from 10 to 80. So change in temperature is 80 minus 10. So mass of steam 540 plus 100 minus 80 is 20, equal to 20 into 70 here. So mass of the steam that is contributing for all this is 20 into 70 by 560. So these two can be cancelled. So 20 into 7, 140 by 56, that is 2.5 gram. So what is this? What I have calculated is mass of steam supplied to the system so that steam converted water as well as the total water get to is at a temperature 80 degrees centigrade. But there is already water present because this water who is at 20, whose temperature is raised from 10 to 80, that is still water. At 80, it's water, right? So the total water present is original 20 grams of the water that is available plus 2.5 grams of the water that is available because steam is converted into water. So the total available water is 22.5 grams. That's how we solve the problem. So to solve this problem, simply we have used principle of calorimetry, that when there is no loss or gain of the heat from the surroundings, heat lost by the hot body equal to heat gained by the cold body. Only thing you have to understand little more carefully is steam at 100 before rising to temperature 80, first of all has to convert into water at 100. For that there will be some emission of heat. Again, to fall from 100 to 80 also there is some emission of the heat. That's all is used by the available water, right? That's how we solve this problem to get an answer 22.5 grams. Thank you for watching.